Hello and welcome to our 19th annual exhibit of hydrogen and fuel cell technology. We've been here since 1995 discussing this very innovative field in the energy sector. Often we talk about projects that are large and small. First of all, please have a seat and have a drink. The drinks are on the house and the hostesses will be serving. We talk about large projects or small projects. We talk about innovations that are good for large cities, established infrastructures. We're going to be talking about something that is well adapted to many areas in the world where there is not necessarily an existing grid, where things are in development. We're going to be talking to Scott Chen, who is a field application engineer at Field Energy, and he'll be talking with us about extended renewable energy storage with fuel cell technology. Please welcome with me Scott Chen.
Nice to meet you.
So, Scott, let's have a seat.
Yeah.
Perhaps because this is your first year here on the fair, you could tell us a little bit about Field Energy, the company, when it was founded, and what it does.
Okay, Field company is is built in the 2000s, and we start to cooperate with Ballard in 2002, and now we have the 13 employees in in Taiwan now, and we're still growing. Mm-hmm. Yes, so we are focused on the stationary fuel cell systems, and then now we got many. So we have passed our field air products about got UL, CSA, and CE certification, and I can say we are the first companies to get these certifications in Asia. Mm-hmm. And we attend many education and training service to teach the fuel cells what it can impact in our life. Yes.
Now, what you're highlighting this year in 2013 is what you call the UEH, the utility power. It's a utility power storage and hydrogen producing unit, an electrolyzer is built into it. So could you tell us a little bit about this system and perhaps how it also relates to this wonderful building we have in front of us here?
Yes, we bring these models to HANNOVER exhibitions. And this is the model ideas for our UES, the product. The green and the white unit is our product. And it can connect to the PV power's supply solution and the wire power. The most important is we will storage the power, the extra power from the PV power or the wind powers, then storage it to the hydrogen tank. And you can take the supply the power from the fuel cells at the moment what you wanted to supply to your light, supply to your electricity, computer, or any other electric units. That's very good because always we use the battery to storage the PV power or the wind power. Mm-hmm. The storage is maybe convenient and very cheap in the installation. But in every 3 years past go or the 5 years past go, you must replace all of the batteries. Mm-hmm. The battery vendors always tells you, I just guarantee 3 years, and you must replace all of this. Mm-hmm. And then that will be a lot of the cost about this. Mm-hmm. But if you install the UEH systems, you can storage these renewable energies to the hydrogen, and the hydrogen tank will be declared in after 3 years or 5 years. Mm-hmm. So you can research there for long-term times. Mm-hmm. That's great. That's what we will UEH the systems ideas. Mm-hmm.
Okay, so we've got, to break this down into simplistic terms for the audience, we've got the photovoltaic, the solar power, being used at the same time, the wind power, and of course the production of solar or wind can fluctuate and fluctuate and fluctuate. So on this, I tend to think of this as a building with a lawn here, and on the left-hand side, you have an electrolyzer. And if you're not using the power, directly at the time. You can use electrolysis, it creates hydrogen, and you store the hydrogen and use the hydrogen when you need it.
Yes,
Okay.
that's the idea.
So this also combines, obviously, then a PEM cell somewhere that would use the hydrogen to convert it back to electricity.
Yes, yes.
Okay. For me, it's interesting. People focus on certain sources of energies in different places of the world differently. For instance, the North Sea is really windy, so we focus on wind there. Is this particularly adapted to the environment within you work? Here you are combining wind power, but particularly solar power. So is this a model produced for a specific environment, for example, in Taiwan? Or do you think of this as a model that is can be adjusted and applied to various other places on the globe where there's more sun but less wind, or more wind but less sun?
Absolutely. It can combine with the wind power or the solar powers as the customers needed, because some places need solar power because he have the assumptions very in the maybe the 300 days in a years. But in other sides, maybe the wind powers, maybe have so many places you don't have the assumptions, but they have the wind powers. But they was combined to a charger or converters, because we use the renewable energies. You need something to storage his energies. Renewable powers cannot save their energies for now, so we transfer it to the batteries. Yeah. So UEH can suitable for any kinds of the DC kind, or the AC or the AC wind powers, or the DC about the solar powers that can suitable for them, and transfer to our electrolytes, then can generate the hydrogen storage in the storage tank. Yeah.
Okay. Now, when I look at this building, it's kind of difficult to tell whether that is a business or a residential home. What type of market are you addressing with this structure? Is it a residential model, or is it something that could be scaled up for small businesses or small industries? Who's the consumer you have in mind with this model?
Actually, not only the industrial using all the signal towers, but also it can use in the residential use. Just have you need emergency backup power systems. Everybody can need a backup of systems. When you have no AC green powers, or the wind power, or not the PV powers, you need another type backup power for your electricity unit. Yeah. So you can suitable for all of this.
Okay. Is this unit designed to be off-grid on a permanent basis? That is, does it exist as a self-standing supplier of energy without relying on the grid at all? Or is this a backup power system? Which direction are you going? Do you want to install this in an area where there is no electrical grid? Or is this a unit that you install in an area where there is an unreliable electrical grid, so you only use the solar power and wind power and the hydrogen when the grid goes down?
Yeah, this idea is suitable for some place without a reliable power source, such as many places don't have a green power very reliable or continuable. So he needed to use the PV power or the wind power. So our product UEH systems can suitable for the PV power and the wind power. So our customer always had their installation didn't have any green powers. They just use the wind power or the PV power. So we see the market, so we created these systems for them, and without it can reduce the battery numbers Because with this PV power, you must use the battery to storage. And if you parallel with our UEH systems, you can reduce the power, the number of the battery. So it can reduce the cost after 3 years or 5 years. Yeah.
Okay. When we talk about power in a unit like this, we might want to know just how many kilowatts are produced from this system. Is this a 1,000 watt hours or an 8,000? Is it scalable? Can you go up or down in numbers? What size of power output are you planning here?
Yeah, this is the standard UEH product. This is designed for the telecom equipment. So this is the standard 1 kilowatt for the telecom equipment. So this output is about 48 voltage to 54 voltage. And 1 kilowatt. And in a standard product, we can provide 8 kilowatt hours for the telecoms. So maybe your grid is dead or the battery is dead and PV dead, we can supply 8 hours for your telecom equipment to continue supply this very continuous working. Yeah.
Okay. I rather like your job title as field application engineer.
Yeah.
You're involved in actually getting these things up and running on the ground. Have you got any demonstrations of how this operates on the ground? How much experience do you have with using this system?
Oh, this is, and we installed about 10 different customers, and the Renewable, and the recent customer is in Australia for the telecoms. So we have tested with him, our customer, for about over 1 year. Yes, and it is a reliable turn on and turn off. It can produce the hydrogens. We experience about 6 cycles about that. You can refuel it and use fuel cell generate 1 kilowatt 8 hours. Then we will return these cycles. Yes.
So for the time being, Australia is a market for you. This fascinates me. Okay, in the land of kangaroos. When I visited your booth, you had another unit, which is not here on stage, but it also addresses another question. That is, when you produce a lot of hydrogen, you may want to store it. So you have a storage unit at your booth that I was looking at.
Yes, that's another type, but that is a cylinder. Yes, it's a little cylinder can to storage about 450 bar. It's a high pressures, yes. And but now we use the low pressures. Our storage per pressure is 30 bar.
Okay.
So
for this unit, it's 30 bar.
Yeah, this unit that is for another unit. So that's kind of the cylinder is for another type, not this type. But this type we use the cylinder. For now, we use the cylinder for his storage. But in the future, we have a very big high tank. It depends on our customer and how much hours you need, and you will need a big or a small tank to storage your hydrogens. Yeah.
The low pressure tank must be an advantage, at least in the respect that high pressure tanks use, if you go up to 700 bars, they use 70% of the energy in the hydrogen just to pressurize the hydrogen. So the low storage pressure is basically an economic factor. You waste very little energy when you store it. This is fascinating. There are strange issues that crop up when you install these technologies in various environments. And when you mention Australia, we were talking during the preparation about things like water consumption.
Oh.
Now, this is fascinating for me because mostly in Germany, we don't think of water consumption as a big problem for hydrogen fuel cells and hydrogen systems because there's lots of water. Berlin is just like parked in mud with rivers around it. But if you're in Australia, you may have an issue. You may have a problem how much water this system consumes. So you actually know the statistics of how much water the system consumes while it's operating. So what water does it consume? How much?
It's less than 0.1 liters per hour, but it can generate 100 liters hydrogens per hour. Because in the desert or in Australia, this is very hot. So we will be careful to design it. We will the efficiency because the water is our design. This is where places in very far away from the cities. You can drive a car 1 day to reach this station. So we have the very big tank in our UEH system, about 50 liters, and it can support maybe about 6 times to refill our H2 storage tank, six cylinders. Yes, so you don't have to check it every years. You just check the cylinder. You just to maintain it per years because the water is very huge. So you don't need to refill the waters every week or every month. You just 1 month, you just 1 years to check it. Yes.
Okay. And this, of course, the whole advantage when you're servicing a remote location far away from major cities.
Yes.
I should add, before we finish our conversation, if there's any questions from the audience, feel free to ask, and we'll try our best to deal with them. There are, for remote power, there are various approaches, I suppose. This combines both wind and solar. Have you run into any difficulties implementing them? For example, this system, when you mention Australia, it may be largely a warm climate that you're talking about. I come from Canada, so some of the remote locations that we have to provide with electrical energy, they're way up in the north where it's very cold.
Yes.
So if you're in a very hot climate, is this system good? And what happens if you try and take this to a very, very cold climate? Would you have to modify it? Would it still work?
Yeah, it still works. But in the low temperature, you cannot use it to the -20 units. -20 need another low temperature solutions. For now, we can in hot weather there's no problems. We can test it in 40 degrees. That is operates very well and still working. So about any function is fine. So that is okay.
Okay, and just a general question, of course. You're here at the Hanover Fair for the first time, and your mission here, what would you like to achieve here during the week at the Hanover Fair? What would you like to achieve? Some people are here looking for research and development.
Oh, yes.
Other people are looking for direct clients that they can sell to. Other people are looking for distributors. They've already got a product and they'd simply like to market it. So
we have got this product in the field and we test over 1 year. So we are ready for that, and we have a solid product and service. If you have interest about a product, you can go into our booth and talk about this. For now, we are looking for the local distributors for our products. If you're interested, please go to my booth and we can talk about that.
Okay. I'll repeat that message. I've been talking to Steve Chen, who is field application engineer and a specialist in operating these remote energy systems from Field Energy. His booth is D662, which is just around the corner.
Yeah.
And he'd be happy to talk to you. Anyone who's interested in distribution of this wonderful system, a freestanding approach to energy supply in remote locations, and also a backup auxiliary unit. Scott, it's been a pleasure talking to you. I hope to see you back here next year, Scott.
Yes.
Okay.
Thank you.
Thank you very much.
Thank you.
And thank you. We've come to, I believe, the end of our program, unless our moderator, Marie, would like to come up and market another. No. Okay. Well, failing that, Marie, we'll wrap up our program for today. That's the end. We're going to be transitioning now to our program for our exhibitors here. It's been a pleasure with you this afternoon. Thank you again, Scott. Thank all of you. And come see us tomorrow.